Warning, the video you're about to watch contains mathematics at the level of college algebra and trigonometry. All material has an assumed prerequisite of both Algebra 1, which is elementary algebra, and Algebra 2, which is intermediate algebra. While some prerequisite topics are reviewed briefly, a more thorough review of these entrance topics can be found by searching the web.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcome.
Hello, my name is Roy Simpson, professor of mathematics at Cosumnes River College in Sacramento, California. This video is meant as a review for rationalizing and numerators and denominators, and that's for students who have already gone through elementary and intermediate algebra. You're either in a college algebra course about to go into calculus or a pre-calculus course, again, about to go into calculus. I cannot emphasize enough how important this skill is actually as you walk into a differential calculus class. You need to know how to rationalize. It's super important. Now, one thing you're going to notice in this review video is that I don't write down a method, I just do it. I'll talk through how things are done when you're rationalizing, but still, I apologize that I just don't write out actual methods or recipes. I do that generally for the course before the course that you're currently in. So let's go ahead and just review a little bit here. Rationalize and simplify the statement. Now, I will still mention the tactic to doing this because you can't avoid it. You have to be able to talk about it. So let's go ahead and talk about that. If I want to rationalize an expression like this, notice where the radicals are. Both the radicals here occur in the denominator. And that means that I'm going to actually rationalize that denominator. When you're asked to rationalize, you'll multiply both numerator and the denominator of the expression you've been handed by the conjugate of whatever radical expression is in that denominator. Now, if you don't remember conjugates, let me just quickly review that off to the side. The sum or difference of two expressions is actually the difference or the sum of those original expressions. In other words, you just flip these signs right here. If it was an addition between A and B at first, it will be a subtraction. If it was a subtraction of B from A, it will be an addition of A and B. So that out of the way, let's talk about what the conjugate of this denominator is. Well, you can see two expressions in that denominator, the first, the second. And so what we're going to do is multiply both numerator and denominator by the first, again, this guy right here, plus the second. Now, I like to use a different color for this, so I'm going to go ahead and grab that numerator and be very, very careful here, because what ends up happening is a lot of people tend to avoid using parentheses. Parentheses are incredibly important. It's not just a silly little symbol or a grouping symbol that you can just leave off. It would be wrong if you left off the grouping symbol. So it is the parenthesis or the group of the square root of 1 plus t plus the square root of 1 minus t, and that's over, again, the same picture. Now, before you go any further, you would be completely incorrect if you left it this way, because in that denominator, if you were to leave it that way, you're essentially saying that this is only multiplying that last radical expression, and that's not what's happening. So I'm going to go ahead and put brackets around this entire denominator so I know it's a binomial multiplication, or the product of the sum and difference of two expressions. Now, as an aside, I want to remind you of something very special about the product of conjugates. There is a formula you learned way back in elementary algebra, probably in junior high or elementary school. First squared minus last squared. It's called the difference of squares. And that first squared minus last squared, you know, can factor into first minus last times first plus last. If I gave you an expression like x squared minus y squared, you would probably know immediately how to factor that. But what we're doing here is the opposite of factoring. Take a look at those denominators. They are first minus last, and then if you take a look at the next factor or the next expression, it's the same first object plus the same last object. So we are really doing a difference of squares multiplication here. This product will end up becoming the difference of squares. And for conjugate multiplication, this will always be true. It will always be a difference of squares multiplication, which means that I don't really have to multiply everything out. I kind of know the trick to it. It's just going to be this first object and we're going to square it minus this last object and we're going to square that. So this is equal to a fraction. It doesn't need to actually be that big. I'm just drawing a big bar so that you can kind of compare it to the expression above. But it's a first object squared, which is going to be a 1 plus t, minus the last object squared. And again, that's going to be a 1 minus t. Just use parentheses liberally when you're doing these multiplications. Very, very important that you do that. The other thing I want to mention here, and this is the thing that destroys calculus students, so pay close attention here. When you're doing this multiplication, multiplying by numerator and denominator by the conjugate, you only need to multiply out or distribute the conjugates. This stuff right here, you're distributing out. Do not distribute out the non-conjugate stuff. That is, this stuff right here, do not multiply it out. There's a very special reason why you would never want to multiply that out, and you're about to see it. So if you follow my advice and you just leave that numerator as t times the quantity of the square root of 1 plus t plus the square root of 1 minus t, then something very special happens when you clean up the denominator. Again, I'll just rewrite the numerator. And the denominator, you have 1 minus 1, so those cancel beautifully, and you have a t minus a negative t, which is a plus t, so you have a 2t downstairs. And notice both your numerator and your denominator have a t in common, so you can divide both numerator and denominator by t, and you're left with the following expression. Now, I cannot accentuate it enough. You do not want to multiply out the non-conjugate product. You only multiply out the actual conjugates. Those conjugates there, that's what you'll multiply out. The numerator, you will never multiply out. Well, you should never say never, honestly, but when you have variables involved, you're not going to multiply those out. When you have constants, yes, you'll multiply everything out. But if you have an expression that has variables, like you will often have in calculus, then you're not going to multiply out the non-conjugate pieces. And that is because things will cancel. It's meant to. So again, that original expression is equivalent to the square root of 1 plus t plus the square root of 1 minus t all over 2. As the second and final example in this review video, we're going to go ahead and rationalize a statement that doesn't look like it can be rationalized, but again, very common to run this style of statement in calculus. This expression can actually be rationalized. It would be considered as a rationalizing of the numerator when you do that. There's a little hidden 1 down underneath all of this stuff. And so you could actually rationalize that numerator by multiplying both numerator and denominator of this fraction by the conjugate of the numerator. Now remember what I said in the last example, you really only distribute out the conjugate pieces. The non-conjugate pieces you generally do not bother distributing through. But in this case, it's just 1 times that stuff. So that, you don't really need to write 1 in front of that parenthesis if you don't want to. Let's go ahead and distribute out that numerator though. We get down to this and you see that numerator actually cleans up very nicely. The x squareds cancel, so we'll combine those terms. And we're pretty much done. Do not bother rationalizing that denominator because you'll get right back to the beginning if you do that. So we had to rationalize numerators. It does happen that this ends up being very important. This is one of those examples, if you have taken calculus in high school, let's say, this is one of those examples that creeps up when you use L'Hopital's rule. If you haven't taken calculus, ignore everything I just said. All right, those 2 examples should really solidify the review for you on how to rationalize both numerators and denominators. The key here is to use parentheses liberally and to not distribute the non-conjugate factors. Only distribute the conjugates and then clean things up. All right, I'll see you in the next video.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes obstacles getting in our way. Cause affects more than we can sometimes see. Things for what they are and work together until you feel at peace. Says, listen close. Don't talk too much that isn't cold. Sure, you may really hurt inside. It doesn't justify you to speak too loud and cry.